The tortoise and the hare. The tortoise and the hare are having a race. In this tale, the tortoise moves at 50 feet per hour, while the hare moves at 250 feet per hour. The tortoise takes 8 hours longer than the hare to finish. What was the distance of the race? Part A. Let T represent the unknown time in hours that it took the hare to complete the race. Write an expression, not an equation, representing the time it took the tortoise to finish the race. To answer Part A, I first want to think about the information I was given in my word problem. So, in the second sentence, I was given the rate that the tortoise was moving and the rate that the hare was moving, but I wasn't really given any information about time. When I look at the third sentence, I see that the tortoise takes 8 hours longer than the hare. So, Part A says, let T represent the unknown time in hours that it took the hare to complete the race. So this is actually T. And I know that the tortoise took 8 hours longer, so 8 hours more, which means my expression for the tortoise's time will be T plus 8. Notice, because I was asked to write an expression and not an equation, this expression, T plus 8, does not have an equal sign. Equations have equal signs, expressions do not. Okay, now Part B says, write 2 equations that represent the race, one for the hare and one for the tortoise. Before I dive into that, I actually need to define another variable. Our first variable, T, was defined in Part A as the time in hours it took the hare to complete the race. Our other variable, we can figure out what needs to be defined by looking at the question. The question says, what was the distance of the race? Which means the distance is unknown and we can represent it with a variable. So let's say, let D equal the distance of the race in feet. Okay, I'm actually going to write my equation for the hare first. So I'll start with D, the distance the hare ran, is 250 feet per hour, that's the rate, times T, that's the time. Right, so distance equals rate times time. Next, I'll write the equation for the tortoise. I'll start it the same way. The tortoise is running the same race, so D, the distance of this race, is the same. And it is equal to the tortoise's rate, which is 50 feet per hour, times the amount of time that the tortoise was racing for. In this case, we take our expression from Part A, T plus 8. That's how long the tortoise was racing for. So that becomes our time, and again we have distance equals rate times time. Okay, Part C. What is the distance of the race? First, I'm going to take my 2 equations, D equals 250 times T, and D equals 50 times the quantity T plus 8. And I'm going to use the equal values method and say, since 250 times T was equal to D, and 50 times the quantity T plus 8 was equal to D, they must be equal to each other. Now I can just undo until I isolate T. My first step here, I'm going to rewrite the left as 250T. And on the right, I'm going to distribute my 50 to both terms inside the parentheses. So I get 50t plus 8 times 50, which is 400. Next, I want all of my t's on one side of the equal sign, and I just prefer to keep them positive. So I'm going to subtract 50t from both sides of this equation. On the left, I now have 200t, and on the right, 50t minus 50t is 0. So all I have left is this 400. Lastly, I need to divide both sides of the equation by the coefficient on t. So the coefficient on t in this case is 200. So I divide both sides by 200 and get t equals 2. But hang on a second. I'm not actually done answering this question because C is asking, what is the distance of the race? I just found how long it took the hare to complete the race. In order to find what the distance of the race is, I have to take this value for t, 2, and plug it in to one of my equations. If I wanted to be extra sure, I could actually plug it into both equations to make sure I get the same thing both times. All right, I'm going to start with this equation first. D equals 250 times t. Well, now we know t equals 2. 250 times 2 is 500. So to be sure we've done this correctly, let's plug 2 into the other equation for t. So we have d equals 50 times the quantity, t plus 8. This t is now a 2. 2 plus 8 is 10. 50 times 10 is also 500. All right, we've done it. Last thing we should do is write our answer as a sentence. The distance of the race is 500 feet. Okay, now let's do a little standard 3 review. We're going to write a system of equations representing this word problem. You are running a concession stand at a basketball game. You're selling hot dogs and sodas. Each hot dog costs $1.50, and each soda costs 50 cents. At the end of the night, you made a total of $78.50 by selling 87 items, hot dogs and sodas combined. How many hot dogs were sold and how many sodas were sold? Try this one on your own, and remember, the first thing you need to do is define your variables. Okay, so like I said, the first thing we need to do is define our variables, and to figure out what I should define, I'm going to look at my question, my last sentence here. How many hot dogs were sold and how many sodas were sold? Since those are the things I don't know, they are unknown, those are the things I'm going to define my variables as. So I'm going to say, let H equal the number of hot dogs sold, and let S equal the number of sodas sold. Maybe you use different variables, that's fine. They should definitely be defined as the number of hot dogs sold and the number of sodas sold. Okay, now looking through the text, I see each hot dog costs $1.50 and each soda costs 50 cents. So one of the units I'm dealing with is money. So I'm just going to make a note of that. At the end of the night, you made a total of $78.50, okay, so more money, by selling 87 items. Okay, so that's my other unit, is just items. I'm going to make a note of that over here. So I know that every hot dog is $1.50, and I sold H hot dogs. So the total money I brought in from hot dogs is H times 150, or 150H. In the same vein, each soda costs 50 cents, So the amount of money I brought in from sodas is 50 cents times the number of sodas sold. The final piece of information I have about money is that I made a total of $78.50. So I'm going to add that to my notes here. So a total means everything combined or everything added together. Now I can construct my first equation for this system. I can say the amount of money brought in from hot dogs and the amount of money brought in from sodas is $78.50. Okay, that's our first equation. Our second equation is about the number of items. Well, we defined H as the number of hot dogs sold and S as the number of sodas sold. And in this sentence it says we sold 87 items. So the number of hot dogs and the number of sodas total 87. And that's it. This is my system of equations. 2 variables, 2 equations, good to go.